Okay. يلا. November 2022 paper 4 variant 2. Hmm. يلا. Question 1. Figure 1.1 shows water flowing down a channel into a tank without splashing. Okay, the water is flowing at a rate of 800 kilograms per minute. The length and width of the tank are 3.1 meters and 1.2 meters. The density is 1020 kilograms per meter cubed. Initially, the tank is empty. Calculate the depth of the water after 1 minute. Okay, after 1 minute, give your answer to three significant figures. ماشي. How can I find the depth? I have the mass. Can I find the density? Can I find the volume? Yes, because I have the density. Density equals mass over volume. Volume equals mass over density. Do I have the mass? Do I actually have the mass? Yes, I do. Oh, I can find the mass. Why? Because I have the rate, which is 800 kilograms per minute. Per minute. After 1 minute, after 1 minute, the depth or the mass will be 800 kilograms. It will be 800 kilograms. طيب. So I have the mass, which is 800 kilograms. I have the density, which is 1020. Type 800 divided by 1020 is divided by 1020. Okay, 0.784 meters cubed. Can I find the depth? Volume equals length times width times height. Volume equals length times width times the height. To find the height or the depth, it will be volume over the area divided by the area, which is 3.1. 3.1 times 1.2. Okay, so 0.784 divided by 3.1 times 1.2, which is 0.21075. We have a lot of numbers. need to make it three significant figures on the calculator. It's 0.2107. The 7 هتبقى 0.211. 0.211 meters. The height of the water decreases by 0.42 meters as it flows down the channel. Calculate the decrease in gravitational potential energy. Okay, gravitational potential energy is mgh. Gravitation. mgh, mass in 1 minute. He's asking about each second, صح? Each second, not each minute. Can I find the mass passing in each second? Yes, I'll just divide by 60. Instead of saying 800 kilograms, well, 800 kilograms was in 1 minute. But each second to find the mass, it would be 800 divided by 60. So this is the mass. 800 divided by 60 times G. 9.8, it should be 10, I know, because this is an old exam, but it's 9.8 for the new syllabus, and the height is 0.42. 800 divided by 60 times 9.8 times 0.42, 54.88, you can say 54.9 or 55 joules. 55 joules. Yeah, the water stops flowing. The depth of the water in the tank is 0.8 meters. Calculate the pressure at the bottom of the tank due to the water. Pressure equals rho gh. The density 1020 times g 9.8 times the height 0.8. 1020 times 9.8 times 0.8, which is 7,996.8. You can just say 8,000 pascals. Okay, 8,000 pascals. Okay, pendulum swings with a time period of approximately 1 second. Describe how to use a stopwatch to determine the period or the time period of the pendulum. How can I find the time period of the pendulum? We know the steps. First of all, you need to use the stopwatch. Or first of all, you need to reset the stopwatch. Okay, reset the stopwatch. Reset the stopwatch. Let the pendulum. Okay, swing. Let's say for 20 cycles, for 20 complete cycles. Take the time. Okay, and measure the time, and measure the time. Not okay. Measure the total time, and then divide the total time. Divide the total time by the number of cycles, or by 20. If you say take 10 cycles, okay, then divide by 10. 20 divide by 20, 30 divide by 30. Complete table 2.2 by writing in each space one of the following devices that is used to measure the quantity. Okay, the volume of water in a glass. To find the volume, we need the measuring cylinder. Okay, measuring cylinder. Width of a small swimming pool. Okay, swimming pool. It would be using what? Usually we would say using a measuring tape. It would be using a measuring tape. But he was quite obvious when he said small swimming pool, so we can use a meter ruler. A meter ruler. A thickness of a piece of aluminum foil. This has been removed. Why? Because we will use the micrometer screw gauge, which has been removed. Also, the thermocouple has been removed, so we're not required to know what is a thermocouple or what is a micrometer screw gauge. Yeah, tidal power derives most of its energy from the moon, and part of its energy from the sun. State one other source of power which derives its energy from the sun. Any other power from the sun, such as let's say the wind energy, a solar energy, wind or solar. One other source that does not derive from the sun. He said tidal. So one other source that does not, such as the geothermal, geothermal, or you can say nuclear fission. We have the water turbine driven by the tidal flow that generates electrical power. Explain whether this method of generation is renewable or not. Is it renewable or not? Definitely it is renewable, yes. Why? Because the tides do not stop. The tides are always there. You always have a rise and a fall in the tides, right? So it's an unlimited resource. Okay. Yes, because the tides are continuous. Unlimited resource. Okay. Can I find the power generated? Okay. So the mass passing each second is 6 times 10 to the power of 3. The speed is 2 meters per second. 40% of the kinetic energy is converted to electrical energy. So you can say this is the efficiency. That 30%, it's only 40% efficient. Calculate the electrical power generated. Okay, so you have the mass, you have the speed, kinetic energy equals half mv squared. Half times the velocity or the mass is 6 times 10 to the power of 3 times the velocity, which is 2 squared. Okay, so 3000 times 4, which is 12,000 joules. This is the total kinetic energy. Total kinetic energy. We need only 40% of it. But he wants power. This is energy. How can I find power? Power equals energy over time. Equals energy over time. We know that the time is 1 second each second. So basically the power is also 12,000 because you divide by 1. So it's 12,000 watts. He wants the efficiency, so we can just, oh, he wants the output power. So to find the output power, we just need to multiply by the efficiency. So times 40%, which is 0.4 or 400, 40 over 100. Multiply it, it will be 4,800 joules. I'm sorry, watts. 4,800 watts. Okay, explain in terms of momentum how gas exerts a pressure. Okay, this is a nice question. It has been repeated more than once before. Gas molecules move fast and random. Gas molecules move fast and random in all directions, colliding with the surface, colliding with the surface, changing their momentum, changing their momentum, causing a force when you change the momentum, which is impulse. Impulse equals force times time. Changing the momentum, causing a force over an area, which is pressure. Which is pressure. Okay, okay, that's easy. What happens to the pressure? State and explain the change of the pressure when the temperature is increased at a constant volume. If you have a constant volume, fixed volume, for example, you have a steel structure or a concrete structure. When you increase the temperature, what happens to the pressure? The pressure increases, definitely. Yes, pressure increases. Why? Pressure increases. Why? Because the molecules gain kinetic energy. So you can say that the molecules gain kinetic energy, move faster, move faster. They collide with the walls, okay, with the walls faster and harder and with more and more frequently. More frequently. Okay, more frequently. Okay, next question. Another sample of gases is in a sealed container. Volume 170 exerts a pressure 9 times 10 to the power of 4. The volume decreases by 70 centimeters cubed at a constant temperature. Calculate the new pressure of the gas. Can I find the new pressure of the gas? Yes, pressure equals, we won't say pressure equals force over area, but for this question we would say that the pressure is, or the pressure times the volume is constant, which is P1 V1 equals P2 V2. So we have the initial pressure and the initial volume, which was 9 times 10 to the power of 4, and the initial volume was 170, equals P2, which is the final pressure, times V2. It decreases by 70 centimeters cubed. Decreases by 70 centimeters cubed. Does this mean that the final volume is 70? No, this means that the final volume is 100. Volume is 100. Just divide by 100. Just divide by 100, and the final pressure would be around 1.5 times 10 to the power of 5 pascals. Okay, it decreases by 70, so meaning 170. So actually V2, we can just write it down. V2 is equal to 170 minus 70, which is equal to 100 centimeters cubed. Okay. Next question. An aluminum block after it leaves the furnace. Specific heat capacity. Can I find the thermal energy? Yes, energy equals mc delta T. mc delta T. Do I have the mass? Yes, I have the mass 1200, the C 960, the delta T. Can I find the delta T, the change in the temperature? Yes, 380 minus 20. So basically 1200 times 960 times 380 minus 20, which is 360. Using your calculators, we can calculate it, and we will find that it's a huge number. Okay, so this is 414 million. 414 million. Writing it down, it would be 4.15. 4.15 times 10 to the power of 8 joules. Okay, times 10 to the power of 8 joules. Okay, factory worker. He is standing 3 meters away from the block. State and explain the main process by which the thermal energy is transferred to the worker. Okay, when he's far away, he is far away. How is the energy transferred to him? How is it transferred to him? Is it by conduction, for example? Okay, maybe, but not as much. Is it by convection? No, definitely not. Why? Because he's not standing above it. He's not floating above the furnace. Okay, he's standing away. So it's basically by radiation, or to be more specific, by infrared radiation. Okay, he absorbs this infrared radiation. The infrared radiation travels to him. Okay, it is absorbed by him. Okay, we can say that infrared radiation travels to him and is absorbed by him. State and explain the main process by which the thermal energy is transferred from the outer surface of the solid, okay, to their interior. When they're inside the furnace, how do they get hot? How do they increase their temperature? Metal. It's a metal. How do we increase the temperature of a metal? By conduction. Yes, definitely by conduction. Can I say and free moving electrons? And by the free moving electrons, yes, because you have conduction in which the molecules vibrate. Molecules vibrate, which is the lattice vibration, and then you have free moving electrons. So lattice vibration, lattice vibration. Let me write it down again. Okay, lattice vibration, and you have the free moving electrons between the molecules. Okay, figure 6.1 shows a converging lens and an object OX. We have the focuses F on each side of the lens. Okay, measure the distance IY from the principal axis to the center line of the lens. Can I find the image first of all? Can I draw the image? Yes, I can draw the image. For your knowledge, this image will be a virtual image. Why? Because the distance between the object and the lens is less than the distance between the lens and the focal, or the focal length, basically. Let's draw the lines. First line will be parallel, okay, and then it will refract passing through the focal point, principal focus, and then this line will be extended, okay, behind the image, behind the object this way. And then the second line, let me use another color, okay, which will pass through the focal, through the center. Okay, definitely they will not meet on the other side, they will meet on the same side. When you extend this line behind it, they will both meet at some point. Okay, at some point behind it. Definitely you're drawing using a ruler, drawing quite accurately. Okay, so the image will appear behind the object. What is the distance? You can measure the distance between the object, between the image. This is the image IY. Okay, IY. You can measure the distance between IY and the center of the lens. You need to measure this distance. Okay, don't draw this line. Just don't draw this line. You just need to measure the distance. Can I measure the distance using the ruler? Yes, it will be around. Okay, if you've drawn it quite accurately, it would be around 4 centimeters, plus or minus 2-3 millimeters. Okay, so it should be around 4 centimeters. If your answer is 4.1, 4.2, okay, 3.9, 3.8, again, okay. State 2 reasons why the image is virtual. Why is this image virtual? First of all, why is the image virtual? We said because the distance between the object and the lens is less than the focal length. They do not meet on the other side. It cannot be formed. I always say that it cannot be formed on the screen. Cannot be projected on a screen. The length or the distance between the object and the lens is less than the focal length. Hmm. Figure 6.2, you have the green light passing through a glass prism. Okay. A ray of blue light is also incident on the same path. So basically, you have a blue light passing. Okay. Initially, it was on the same path. Initially, it was on the same path. Inside the prism and then outside the prism. Can I draw the blue light as it goes in and outside of the prism? Yes. We know the colors Roy, Gibev, Roy, Gibev. Okay, so basically green, blue has a smaller wavelength, a shorter wavelength, and a higher frequency. Higher frequency means that it will be refracted more. It will be refracted more. If you had a normal prism, refracted more means that it will be drawn just below the green line. But since this is an inverted prism, it will be drawn, okay, above it. You can say above it, which is if you invert it, it would be below it. So the blue line would be drawn this way, above it, and then okay. So this is the blue line. Oh, this is the blue um, ray. This is the blue ray. Okay. You have the magnetic field around the bar magnet. 7.2 shows a magnet labeled magnet 1 placed in position 1. Okay. Figure 7.2. Draw lines to show the pattern of the magnetic field produced by magnet 1. Place arrows on the lines to show the direction. Can I draw some lines? Yes. You have to draw the lines from north to south. From north to south, above and below. Okay. From north to south. And then you have lines going outwards from the North Pole and then inwards into the South Pole. Okay, this is the hmm, okay. So you have two, at least two of them above and at least two of them below. If you want to draw three, it's okay. From north to south. Magnet 1 is removed from position 1. Figure 7.3 shows another magnet labeled magnet 2 placed on position 2. On figure 7.3, draw the right hand end position of, okay, at the right hand end of position 1. A line with an arrow to show the direction of the magnetic field produced by magnet 2. Produced by magnet 2. So what happened is that magnet 1, can you see magnet 1 from figure 7.2? Okay, is removed from position 1. Figure 7.3 shows another magnet labeled magnet 2 placed on position 2. Okay, on figure 7.3, draw at the right hand end of position 1, at the right hand, at this position, a line with an arrow to show the direction of the magnetic field produced by magnet 2. So isn't this a north pole? Yes, it is a north pole. In which direction, in which direction does the north pole, or does the magnetic field due to a north pole, okay, in which direction should I draw the magnetic field due to the North Pole? We should draw it moving outside or outwards from the North Pole and then inwards towards whatever position this is. Okay, so we can just say it's moving this way. You can just say it's moving in this way. Okay, on figure 7.1, now we have 7.1, shows magnet 1 placed on position 1 and magnet 2 in position 2. Again, okay. State the direction of the force that north pole of magnet 2 exerts on the north pole of magnet 1. Magnet 2 exerts a force on magnet 1. What type of force is this? It's a repulsion force. It's a repulsion force. So basically it's pushing it away. Magnet 2 will push magnet 1 away. In which direction? To the left. To the left. Justify your answer because repulsion. So you can say that um, okay, you can say that repulsion. You can say that same poles repel, okay, like poles repel. You can say that north poles, the force on the north pole will be to the left, or whatever. The light intensity at the circuit increases from dark to bright. Basically, the light increases. Let me write down that the light increases. And we have an LDR. Isn't this an LDR? Component Y is an LDR. State any effect this has on the resistance of LDR, of the LDR. As you increase the as you increase the light, what happens to resistance? It decreases. So we can say that the resistance decreases. State and explain any effect this has on the reading of the voltmeter. As the resistance decreases, the voltmeter is parallel to the LDR. It is parallel to LDR. So the resistance, as the resistance decreases, it will also, yes, the voltage will also decreases. Yes, the voltage or the reading decreases as well. Circuit shown in figure 8.2 is switched on for 2 minutes. Switched on for 2 minutes. The current is 3 amperes. The resistance is 4 ohms. The magnitude on charge on one electron is 1.6 times 10 to the negative 19. Find the number of electrons that pass each second. Okay. How can I find the number of electrons that pass in each second? I need to find first of all the charge. You need to find the charge. So I equals Q over T, or you can say that Q equals IT. Q equals IT. The current is 3 ohms, 3 amperes, I'm sorry, and the time is 2 minutes. 2 times 60. Okay, so 3 times 2 times 60 is 360 coulombs. 360 coulombs. This is the total charge. This is the total charge that has passed. Total charge that has passed. How can I find the number of electrons? Basically, we can write down a simple ratio. A simple ratio. If I say the charge, okay, The charge on one electron and the number of electrons. Charge on one electron is 1.6 times 10 to the negative 19. What if I have 360 coulombs of charge? Can I find the number of electrons? Yes, it's a basic cross multiplication. 360 times 1 divided by 1.6 times 10 to the negative 19. So basically, all you need to do is 360 times 1 divided by 1.6 times 10 to the negative 19. Again, you can use parentheses. Please do use parentheses. Okay. And the final charge or the final number of electrons would be around 1.9 times 10 to the power of 19 times 10 to the power of 19 electrons. Calculate the power dissipated by the resistor. Okay, this is easy. Power equals VI. You have the voltage of this resistor, yes. You have the current, yes. So 3 times 12 is 36 watts. Yeah, that's easy. Question 9 is cancelled. Okay, so you're in luck today. All of question 9 is cancelled. It was quite easy. It was quite easy. It has been removed. All of question 9 has been removed. Okay, question 10. The magnitude of the charge on a beta particle is 1.6 times 10 to the negative 19 coulombs, okay, which is the same as an electron. We just solved it. State the proton number and the nucleon number for an alpha particle. Okay, that's easy. Proton number is what? Proton number, it's 2. Nucleon number, the mass number, 4. Okay, two very easy marks. Determine the magnitude of the charge on an alpha particle. Magnitude of the charge is what? So an alpha particle is charged positive 2. Positive 2. And he said that the magnitude is 1.6 times 10 to the negative 19 coulombs. 1.6. So if you have two charges, two positive charges, beta is a negative charge. So you can say it's negative 1.6 times 10 to the power of 19. What about an alpha particle? It would be positive 1.6 times 10 to the negative 19. That's if it had only one proton. It has now two protons. So basically, you'll just multiply 2 times 1.6 times 10 to the negative 19, which would be 3.2 times 10 to the negative 19. Okay, positive charge. This is the positive charge of an alpha particle. I'd find some people might ask, would the charge be 3.2 times 10 to the positive 19? No. The power, okay, positive 19 or negative 19 does not affect the charge whether it is positive or negative. This is the magnitude, meaning that you have 19 zeros. It should be 0.0019 zeros and then 332. Okay, that's the charge. It does not affect whether it's positive or negative. It doesn't affect whether it's you can say that the charge is positive 3.2 and that for the beta it is negative 1.6 times 10 to the negative 19. But the power, okay, the negative power does not affect whether it is positively charged or negatively charged. Okay, radium 230 has 88 protons, 142 neutrons. Radium 230 is radioactive, decays beta, okay, to produce actinium. Okay, the symbol for the radium is Ra, actinium is Ac. Can I write down the nuclide equation? Yes, I can write down the nuclide equation. It's more of a chemistry question. Initially, it was radium. Okay, radium, Ra, 230. Okay, 230. And it had 88 protons. Okay, I'm sorry, 230. 230, it had 88 protons. So it had 88 protons. This is radium in the initial, okay, radium. And then it produces what? It produces a beta particle and actinium. Okay, it produces beta and Ac. Beta is always 0 and -1, meaning that the mass number will not change, but the proton number will actually increase by 1. Why? Because if you add -1 and 89, it will be 88. 89 plus -1 will be 88. The half-life of radium-230 is 93 minutes. A sample contains 9.6 times 10 to the -19 grams of radium. Calculate the mass of radium after 279 minutes. ماشي, okay, that's not hard. It's quite easy. 93 minutes. Okay, so we have the total time, which is 279 divided by 70 divided by 93, which is 3 half lives. Meaning that we will divide by 3, divide by 2 how many times? 3 times. Divide by 2, 3 times. The initial mass, we don't have any background radiation, so we don't need to subtract or anything. The initial mass was 9.6 times 10 to the -12 divided by 2. How many times? 3 times. So 9.6 divided by 2 is 4.8. Okay, 4.8. So this is the first half-life. Then divide by 2 again. 2.4. Then divide by 2 again. Is 1.2 times 10 to the -12 grams. This is the final mass after the final mass after 279 minutes. Okay.